Welcome back. Let's go ahead and talk about half-lives today. Half-life calculations are a very commonly used multiple choice style question by College Board. So the odds are you will see one on your exam in May and will be more than prepared for it. Let's start off with reading. The half-life of strontium-90 is 25 years. How much strontium-90 will remain after 100 years if the initial amount is 4.0 grams? Okay, actually I'm getting ahead of myself. What is a half-life? The half-life is the amount of time it takes for 1/2 of a sample to radioactively decay. It's pretty much right in the name. Now there's a lot of numbers in here, so we're going to eat the sandwich one bite at a time. The question wants us to end up with how much strontium will remain after a certain amount of time, but that's dependent on the number of half-lives, and we know the length of a half-life, but we don't know how many half-lives that is. So we're going to take our total time that's passed, total time, that's not how you spell time, and divide that by the length of a half-life. Our total time is 100 years. That came out of our problem. And our length of a half-life is 25 years. That also came out of the problem. 100 divided by 25 is 4 half-lives. So that's cool. But again, that doesn't answer our question. Our question wants to know how much of a sample would remain. This is where we start applying a wonderful table. We have mass, we have number of half-lives, and then we won't need it in this problem, but we will need it in future problems, fraction/percent. So our half-lives are always going to start at 0, then 1, 2, 3, 4. Not all of these will stop at 4, but I know that after 4 half-lives, I'm done. At 0 half-lives, at the beginning of my time, I have 4 grams, and my fraction would be 1/1. Now, with each half-life, I'm dividing my remaining mass in half. So after 1 half-life, 1/2 of my sample remains. After 2 half-lives, 1/4 of my sample. After 3 half-lives is 1/8, and after 4 half-lives, I have 1/16 of my sample remaining. Now that's cool, but let's put some numbers on there. Each step in a half-life, you're basically dividing the remaining mass by 2. So 4 divided by 2 is 2. Divided by 2 is 1. Divided by 2 is 0.5. And divided by 2 is 0.25. My mass was in grams. So after 4 half-lives, I probably have 0.25 grams remaining. Now, this is why I like to include the fraction part, because now I can go ahead and check. If 0.25 grams is 1/16 of my starting amount, in this case 4.0 grams, I'm good. I've done my math correctly. So what I can do is I can do 4.0 divided by 16, and it will come out to 0.25 grams. So I am correct. 0.25 grams, and it's a present, so put it in a box. Nice. Let's scroll down and pick another one. Here we go. What is the half-life of a 100.0 gram sample of nitrogen-16 that decays to 12.5 grams in 21.6 seconds? So we've got a lot of numbers, but what's important here is that this time we're not calculating how much is remaining or what fraction or anything like that. We're figuring out what the half-life is. So we need to approach this problem from a different angle. We're still going to write our little tables. We have our mass. We're going to have our number of half-lives. And let's have our fraction remaining. We have 0 half-lives, 1 half-life, 2 half-lives, 3, 4, 5. We'll go further if we need to. Fractions at 0 half-lives, we have 1 out of 1, 1 half, 1 quarter, 1/8, 1/16, 1/32. But wait a minute, how can you fill in all those numbers without knowing your starting masses? Because it doesn't matter. In these tables, the only numbers that will change are your masses. Your number of half-lives and fractions are a fixed relationship. After 1 half-life, you will always have 1/4 of your sample that is not decayed. After 3 half-lives, you will always have 1/8 that has not decayed. Those relationships do not change. Now I can go in and put my masses, since those are the numbers that change. At no half-lives passed, I have 100 grams. At 2 half-lives, 1 half-life, my bad, I have 50, 25, 12.5. Oh, wait a minute, that number sounds familiar to me, because that's how many grams are remaining at the end of the problem. And I know that that is 3 half-lives, but I'm still not there. The question wants to know, what is the length of the half-life? Okay, well, 21.6 seconds total have gone by. 21.6 seconds total. And I know that in my equation, total time divided by length of half-life tells me number of half-lives. Number of half-lives. Now, I do know that my number of half-lives is 3. So let's go ahead and substitute this. Now, you can rearrange the formula, but you get 21.6 divided by 3. Oh, my bad. That says total time. That should say length of half-life. Let's keep that our little secret. No one's going to watch this video anyway, so that's okay. So 21.6 divided by 3, 1 half-life is equal to 7.2 seconds. Don't forget the unit. 7.2 is a number, and the question is asking us how long, what is the half-life, so it needs to be a measure of time. And then the rest of the problems are all variations of that. So you can either ask me if you're stuck, or reference the other video that I'm attaching, because I'm sure it does a much better job than I did.